This is the modern periodic table as given by Henry Moseley. This is the present accepted form of the periodic table, which includes 118 elements that have been discovered so far. Well, don't worry, we will not deal with the entire periodic table right now. We'll deal with only this part of the periodic table. So we know that the horizontal rows in the periodic table are known as periods. Let's see if these elements in particular periods follow any particular trend. So let's see. The first period. Period 1 has elements hydrogen and helium. The electronic configuration of hydrogen is 1. Electronic configuration of helium is 2. The second period. The first element of the second period is lithium and the last element is neon. Let's see. So the second period starts with lithium, ends with neon. So the electronic configuration of lithium is 2,1. Electronic configuration of neon is 2,8. Let's see the third period elements. Sodium is the first element of the third period, has electronic configuration 2,8,1. The last element, argon, has electronic configuration 2,8,8. Are you able to observe any particular trend here? Let's see. So the elements of period 2, they have 2 shells. Elements of period 3, they have 3 shells. Let's observe the fourth period. It starts with potassium, which has electronic configuration 2,8,8,1, ends with krypton. It has electronic configuration 2,8,18,8. So the number of shells are 4, and these are the period 4 elements. Same is true for the elements of period 5, starts with rubidium, has 5 shells, ends with xenon, which has 5 shells. So in case of periods, we can conclude that the period number is equal to the number of shells. If you remember, the group number is equal to the number of valence electrons. In case of periods, all the elements belonging to a particular period have the same number of shells. Let's take a particular period, period 3. The elements of these period are sodium, magnesium, aluminium, silicon, and so on. So we know that the period number is equal to the number of shells. So each of these elements have 3 shells. Also we know that the group number is equal to the number of valence electrons. So group 2A, it has 2 valence electrons. Group 3A has 3 valence electrons, and so on. So these are the period 3 elements. They show this behavior in their electronic configuration. So let's see one more thing. The first element, sodium, has electronic configuration 2,8,1. It can easily lose this 1 electron to complete its octet, so its valency is 1. The second element, magnesium, has 2 electrons in the valence shell, can easily lose these 2 valence electrons to complete its octet, hence its valency is 2. So is it for aluminium, it loses 3 electrons to complete its octet, its valency is 3. So the elements that lose electrons to complete their octet are known as metals. Silicon has 4 electrons in the valence shell. It neither gains nor loses electrons. Instead, it shares 4 electrons. This is known as metalloids. Phosphorus has 5 electrons in the valence shell. It can gain 3 electrons to complete its octet. Its valency is 3. Sulfur, 6 electrons, gains 2 electrons again to complete its octet. Chlorine has 7 electrons in the valence shell, gains 1 electron. So the elements that gain electrons to complete their octet are known as nonmetals. The last group of elements, we know they have 8 electrons in the valence shell. They are noble gases. They do not take part in any chemical reaction. Their valency is 0. So they are inert or the noble gases. So this is for the periodic table. The elements belonging to groups 1A, 2A and 3A, these are metals. The elements belonging to group 4A, they are metalloids. Elements belonging to 5A, 6A and 7A, they are non-metals. And the last group of elements, they are noble or the inert gases. So each atom of an element X has 4 shells. To which period does it belong in the periodic table? We know that the period number is equal to the number of shells. This is true for all the elements in the periodic table. Any element belonging to a particular period has the same number of shells as is the period number. So if an atom of an element has 4 shells, it belongs to period 4. Okay. So most of the time we are dealing with this part of the periodic table. Why? Because if we consider the elements from 1A to 7A, we leave the group 8A elements. These elements show most of the chemical reactions that take place around us. Also, they are the most abundant elements in nature. That is why these elements are also known as main group elements or representative elements. They include elements of group 1, which are known as alkali metals. They include elements of group 2, known as alkaline earth metals. They include elements of group 13, 14, 15 and 16, and also the group 17 elements known as halogen. So we saw that the representative elements include elements of group 1A known as alkali metals, elements of group 2A known as alkaline earth metals. The elements from group 13 to 16, they do not have any particular name. At times they are referred to as boron family, carbon family, nitrogen family and oxygen family. The group 7A elements, they are known as halogens. The elements in between, these elements are known as transition elements as they show transition of properties from this side of the periodic table to this side. And the elements that are placed separately, we know which are behind the lanthanum and the actinum elements. They form a separate series and they are known as inner transition elements. Inner transition because we know that they lie within the transition element series. So they are known as inner transition elements. So we saw that elements belonging to particular groups and periods, they show the same trends in their properties, and this is how they are named in the periodic table.